No, I can't
Okay,
see the
just
people,
checking on that one.
but it's nice to be able to see the producers and the directors.
It's overrated.
It is what it is. Hey, look. Is
Wow.
that us?
Oh, there was a little munchkin running there.
I know. See, now you can see me. Now you can see me. I got my
God,
glasses.
I saw your glasses. You cleaned your glasses like a half hour ago.
Hey guys,
Welcome back.
I'm gonna wait a few more minutes just so we have more people on the live. We've got 18 people already.
I think that's all my family. No, just kidding.
Mike, you
know-
can
I
see
didn't
who's
know.
on there. On the screen, you can see who pops up.
Yeah, I don't know any of those.
The doc joined.
One more minute, we'll wait.
Yeah, I had one guy that called the other day that I talked to. The name of his company is Johnny B. Cools. Johnny B. Cools. I love some of the names.
Thanks to Mike for getting me my soda.
Sean's asking what's going on here. It's our Buckle Up with Mike and Brian. So,
It is.
Part I don't even know anymore.
part
How many
2
we
of
did-
electrical
well, it's part 2 of
troubleshooting.
the electrical troubleshooting. But
Okay, let's get started.
Cool.
So, welcome everyone who's watching to our Buckle Up with Mike and Brian. Since everyone loved the last segment, which was on electrical troubleshooting, we decided to do a part 2. So, as always, the goal is to stump these guys. So, you want to ask a really difficult question that they don't know how to answer, and we'll send you some really cool Blue-On stuff in the mail. And then wanted to remind you guys that our next segment is on April 1st at 4 p.m. for charging and tuning. And we also have a contest going on right now, which is actually ending at midnight tonight. So the link is in our bio if you want to join. It's a $1,000 giveaway.
hurry up.
Really big deal. Really cool.
Running out of clock.
They won't let us. They won't let us do it. Though.
I know.
Oh.
We're not eligible.
So yeah, let's start off by covering some basic topics about electrical troubleshooting. So Brian, want to take it away?
Sure. So I'm Brian. He's not. Electrical troubleshooting. You know, we get a lot, and the one that I get a lot of is troubleshooting low voltage wiring between thermostat and the air handler or furnace. So what I did is, look, I made up a little chingadera here for everybody to look at. So subbase on the wall, you disconnect your wires from the air handler or furnace, and then twist all these together, put a wire nut on them. Now you can go back to your thermostat, pull the thermostat off the wall, exposing the subbase, and now you can ohm out all of these wires to see if anything shows up as O period, L period. Right?
You gonna explain that?
Oh yeah, that's
Okay.
That's open line. And now you got the thermostat off the wall. Leave the thermostat off the wall. Now you can go back to the furnace, undo your wire nut, and spread these guys out. And now you can sit there by checking ohms. And for you guys that not sure what that is on your volt ohm meter, and we'll get into that again in a minute. But on your volt ohm meter, it's that upside down looking horseshoey thing. But now that you got the wires all spread back out, now you can take and check ohms and see if any of them are shorted together. Because if you've got the insulation that is split off of these in the wall somewhere, they pulled it, it got caught on something and stripped those wires, and they're shorted, then you could potentially have, as the case was today, where the gentleman called in and said he took the thermostat off the wall, yet the compressor was still running. So sure enough, brand new thermostat wire got pulled, and they stripped it, and he had R touching Y, and guess what that did?
Well, I'd like to take that one step further. When you
You want my wire?
No, I don't need your wires. You can keep your wires. A couple things that'll make things a lot easier for you guys. Get some jumper wires. They are a fantastic tool that you can do a lot of fun things with. Okay. The other thing is you can get alligator clips that will go on your test leads, which makes it really, really easy when you're trying to test wiring and stuff. You can clip one probe on, and you can go to several different places. So, you know, it's just a couple little things, not real expensive, but they can really make your life easier.
Yep.
So, are you done?
Unless somebody squawks at me, Mikey. Foster, after our last buckle up with Mike and Brian, Foster dropped us a line. So Foster, thanks, but we want to go back and kind of clarify or add a little bit more information. So Mikey, why don't you hit that?
Mike, you got a shout out. Someone said loving the sandals.
So does the boss.
Now you guys know why I call him Fred.
I think the question was basically about which is more efficient, 120 or 230. Well, if you're talking single phase, it doesn't really matter. But Foster's point was that if you had 4 of these units and you put them all on the same phase, you were going to have an imbalance. And
right.
He's 100% correct on that. It's one of the problems we had with 3-phase panels, where they would get them very, very overloaded, and you'd have harmonics, you'd have nuisance fuse trips, you'd have nuisance fuse clearing because of the excessive heat. But no, he's 100% right, you know, that you do need to keep your load balanced on a panel. It's just good practice.
Right. And, you know, to look at that, you can even do that at your own house. And you just amp out what's coming in.
Yeah, see, I mean, we couldn't balance it in here because we've got so many young ladies that have got all these resistance heaters under their desk, and we're not sure which phase they're on. So we couldn't balance that one out if we tried. We've even had a few put them underneath the thermostat.
Yeah, which makes the rest of the building really cool, which
Yeah.
is good for me. But hey, for the new guys joining in, we like to have fun, but we also like to share some knowledge. But mostly we just like to have fun.
And for everyone who's joining in right now, a reminder to drop your questions in the chat. Again, this is electrical troubleshooting. So if you have any questions at all that you want them to answer, be sure to leave them in the chat and we'll get to them. And again, we want to stump them. They have yet to be stumped ever on these lives. So maybe you'll be the first one, which is a big deal.
Not going to happen.
Try 'em.
This is way too damn old. And I've got mine. So
That's even older.
But the other piece that we kind of wanted to go over, I mean, electrical troubleshooting, we get a lot of kids calling in that are not really experienced in the trade. They've been in it 5 days to a year. And so I made a joke about the upside down horseshoe. It's the omega symbol, which is ohms, and that's part of your voltometer, otherwise known as a VOM, or multimeter. What else do we call these things? So the tech terms that we use get that electrical chingadera going. That's not really gonna work. But
Brian, what are some of the tools that a beginner would need? What are the best tools that a guy could use when he's starting out?
Well, he needs a decent voltometer and an amp clamp. And you can get those. And when I say decent, you can go to a hardware store and get a decent meter that'll allow you to. It will have the amp clamp on it as well as having a multimeter that you can read AC volts, DC volts, amps, ohms, microamps,
Yeah.
things
All
like
right,
that.
so we have one in the chat from Landwater90, and he asks, What causes low voltage in AC unit?
Well, the low voltage is typically coming from the power company. It just doesn't have a real strong bus. Typically what happens is they overload an area and you get a lot of load on it at the same time and it draws the voltage down. We see it a lot in the summertime when it gets real hot and everybody's running their air conditioners. Instead of having 208 volts, you're down around 170. So that's the biggest thing.
So what causes low voltage, you know, you can take that two ways. What causes low voltage is the transformer. You takes it from high voltage to 24.
Mhm.
So there's one piece.
Mhm.
So,
But if you ain't got much coming in, you ain't got much going out.
but it's another thing, you know, like Mike's saying, it depends on the grid, and it also depends on how the utility companies have powered the building. We're gonna multi-tap transformers. Why did they make a multi-tap transformer? It's for the ranges, because you have a 208, 230 machine, and once you get below a certain amount of volts, your 24 is no longer. Anybody that's actually looked at this and paid attention to it, your 24 volts is not really 24. It's more like 26 to 27. But if you're sitting there on a 208, 230 building, and your main power is 208, 230, and you read your low voltage, your 24 circuit, and you're at 23, chances are you're not at 230 volts and your transformer is tapped for 230. If you're at 209 or 210, you probably need to take that transformer tap from the 230, put it over on the 208 side, and then reread your 24 volts, and you'll find that the 24 volts is back up around 26, 27. So what causes the low voltage? There's a lot of things. It could be the way that the power company is sending it, or like Mike said, with everybody calling for cooling all at one time in the heat, they just can't supply enough to keep your power up at 100%.
Good. All right. One more time, guys. Just leave your questions in the chat. Electrical troubleshooting. Anything you've ever wanted to know, leave them in there. These guys can help you out. All right. So I'm going to move on to a couple questions that were sent in today. This guy is saying, I've always struggled with troubleshooting electrical circuits when they are switching common instead of 24 volts. You put one lead to ground, and if you hopscotch the electrical circuit, you have 24 volts but no operation. Never made sense to me. Can you explain this?
It's just what some engineers decide to do. A couple of them have gone with the theory that they put operating controls in the hot and safeties in the common. There's several different things. When I'm dealing with something like that where I've got multiple safeties on both sides of the coil, I'll turn around and start at the source and work my way in until I find the device that's causing the problem, or the switch that's causing the problem.
Yeah.
Cool.
Getting used to understand that it doesn't matter whether they're breaking the 24 positive side or the 24 negative side. The point is they are opening a circuit which stops the flow. So you want to get 24 volts to the contactor coil. Doesn't matter which side of that, whether I break the yellow wire or the common wire, it doesn't matter which one I break. Any of those will stop that contactor coil from pulling in.
You know, I ran into something the other day. Most manufacturers ground the secondary of the control transformer.
Yep.
And so a lot of times if you're checking your 24 volt side of it, you can just go to ground and work your way in. Well, we were dealing with one the other day where there was no ground on the secondary, and the tech I was working with was trying to reference ground, and he wasn't picking up the 24 volts. So you always want to check and make sure if ground is an actual reference before you start that attack.
And you just made me think of something else too.
I'm sorry.
That I know it's terrible. We had a guy let us know, and I've seen this myself, and that's why I wanted this. This is what do they call those? This would be a safety thing for you guys. Not everybody runs a ground wire from the panel to the unit, and they're using the EMT conduit as the ground, and you walk across the roof, you see those conduits that are broke apart. Guys, don't just take it for granted, reach over there and be a nice guy and try and put those two back together, because if they didn't run a ground wire and the compressors burn up, there's a lot of scenarios that you make contact with those two pieces of pipe and you have now completed a circuit. So if you see conduit broke open on a roof and you want to be the nice guy to fix it, take your meter before you touch that pipe and make sure that it's dead. Make sure there's a ground wire in there, something. I don't want anybody getting hurt, and we've seen it too many times.
Well, you know, one of the things that I've seen happen before is they'll run the output of 2 drives in the same conduit. And so a guy turns off the one drive to work on it.
Yeah.
And he's got power coming back into the drive from the other line, and it gives problems. So it is a good idea to take and put your meter on stuff just to make sure it's safe.
Yep.
You know, I mean, we work with a lot of dangerous stuff. We really do. You know, Brian and I joke and kid around, but we both know people that have been hurt by not being as safe as they should be.
Yeah. I just. Yeah, he found it. I mean, it was a conversation I had with one of my friends, and you know, Jay found the bad compressor and fortunately did not get bit by the unit, because the compressor had grounded, but all that power was because there was no ground wire. It just left the machine hot, and it's scary. It's all.
Yeah, it gets floated.
So be safe.
Yep.
On that note, we got a question from Florida HVACR. Little hard to understand, but I'm going to try my best.
Okay.
When
We'll try and clarify it.
wiring safety float switch, I see a lot of people breaking R, a lot of people breaking Y. What are y'all's preference?
Oh, the float switch he's referring to is what I call them a wet switch. When you're up
What
in
is a float switch?
when you're up in the air handler in the attic, the wet switch is if the condensate drain plugs up and it starts going into the pan, hits the wet switch and breaks one or the other. I mean, yes, a lot of guys will, in my opinion, they wire them wrong because they wire them to short and burn up the transformer. I don't want to do that. I don't want to blow up any pieces of equipment. But if you break the R wire to going to the thermostat, then you have no fan, no condenser, no nothing. If you just break the Y wire or the wire that's going to the condensing unit, you stop the cooling, but they still have fan running. So it's until they get hot. Either one works. I want the customer to know that they have a problem right away, so I would kill everything. Breaking the R wire is what I would do.
We got a shout out from HVACMO, said, "Hey Blue On, you guys are amazing. Love from Baltimore."
Sweet.
Sweet. Talking
Hopefully
about
it's-
Baltimore, we have a new tech in Maryland that's on tech support. Mark Manger, really, really great guy. Enjoy talking to him. I think you'll enjoy if you call in for tech support and get Mark.
All right, another question in the chat. He says 3 amp fuse blown due to 24 volt circuit, 5-ton unit, 13 motor is fine.
X13 is fine.
Yes,
So
that
the
thing.
X13 motor that they're referring to is EMS motor. That's kind of the new replacement, right? ECM.
ECM.
ECM motor. ECM motor. So the 3 amp fuse is blowing on a 5-ton.
Could be anything in your control circuit. Yeah. Could be a shorted thermostat wire.
Thermostat
right there.
wire.
I had one the other day where it was one of the high pressure peanut switches
Yeah.
was shorted,
Yeah.
and so that was clearing the fuse. All you can do is kind of divide and conquer. You know, start disconnecting things, and when you put the wrong thing back in, it goes. I know they've got some little circuit breakers that you can put in line so you don't end up killing a bunch of fuses.
Yeah, instead of burning up a bunch of a box of fuses because you are trying to find it and you haven't quite figured out what I was talking about using your meter, pick up a circuit breaker that you can pull the fuse out, put in the circuit breaker so you're not sitting there constantly doing that. It's not saying leave your circuit breaker behind.
No. No.
That could get expensive, but also having to run to the store and get another 50 fuses, gets a little expensive too.
All right, Steve asks, let's scroll back up. Is it common?
Little poppers are your best friend. There you go.
Is it common to test a MOV following a coil failure?
Oh, you can. I mean, typically my experience with MOVs is they end up split because they took a surge. They took a hit and they'll actually crack, and one part of it will be separated from the others.
What is an MOV, Mike?
Metal oxide varistor. It kind of deadens the spike. Surprised I knew that, huh?
No, I'm not. But there is a kid sitting out here going, "What the hell's an MOV, Mike?"
Kind of looks like a little red lollipop across the coil, and it's there to kind of absorb spikes. In that some coils, when they pull in,
We are
there's a
talking
surge.
voltage spike, yes.
Yes, and they kind of deaden that.
All right, HVAC Mo again. He's asking, can you please explain how and why an outdoor contactor causes a fuse to blow in the indoor board?
If you're talking about the control fuse, then if you had, and here's one of the things that I've seen. If you have a contactor that pulls in and it can't pull in all the way because there's metal shavings keeping it out, it will pull excessive current and cause that control fuse to blow. Typically you'll hear a buzzing out of the contactor.
Yeah. Some chatter.
A lot of times you can just turn around and with the power off, like that disclaimer there, turn the power off, don't try taking it apart before you turn the power off. But you can pull the back off and kind of separate it and clean it up. Sometimes you'll see that there's a lot of corrosion there that keeps it from pulling all the way in.
Okay, well, earlier I had mentioned that 208, 230 tap, and the heat pumps with the air handler, it's a 220 volt air handler, the same thing, the transformer's going to be 2 taps. So if they're running and they're having that problem where it's popping the fuse on the board every time the contactor pulls in, that would be one good thing to check to see if you're getting that 26, 27 volts or if you're at 23. Because if you're at 23, that's how the coil's having a hard time making the contactor pull in fully, and then you've got that higher amper.
I had one just a little while back talking about the low voltage and contactors and all this other fun stuff.
Right.
And they had a lock rotor compressor, and it had a really weak power coming in. So every time, and it was 208 coil. So every time the contactor pulled in, the voltage dropped, the contactor dropped out, the voltage came up, and pretty soon he's got a doorbell.
Yeah.
So
Nice little chatter going on.
yeah. So interesting things to look for.
Cool. All right, we can move on to another one that was sent in today.
Okay.
Someone asks, how do you wire from a disconnect to a control board on a VRV system?
Well, I think that question is, because I don't want to oversimplify it, the manufacturers, because there's the various manufacturers and the way they're doing things, you're either bringing it in and landing it on their lugs, or if they've already, you can use the wire nuts. You can use, I used to call them Kearneys, the
Split bolts.
split bolts.
Right.
I know they've come up with a newfangled way, and
The name of it.
can't remember the name of those, but it's a block. The 2 wires will come in the side. You flip the cap, saves you from having to do a whole bunch of wiring. But I hope I answered that question for you. Usually the manufacturer does give you a way to connect your wires from the disconnect.
Hopefully.
I hope.
there's that one question here about having an issue in the south with faulty contactors from the factory on the low voltage coil, both indoor. So when somebody tells me, but it's brand new, that's
mean
nice.
anything.
It's brand new, but I don't know how many parts I've gotten out of the box that simply don't work.
Well, they put a warranty on a brand new car for a reason.
Yeah, exactly. Sound not working too well.
Uh-oh.
Yeah, we're trying to figure it out. Is it better, guys? Just leave a comment in the chat if you can hear us.
I can talk louder.
I hope I don't have to talk louder. Can you hear me now?
All right, let's move on to a few more questions. Someone asked, how do I check a 24-volt safety with my power on?
Okay. If you have a single safety that's giving you a problem, and you put your meter on a scale that's going to cover 24 volts, and you read across that safety, you're going to read 24 volts. If the safety is open.
If it's open.
If it's open.
If it's not, but then again, you also have to verify that you've got 24 volts there.
Yeah. And
So
you also have
just
to make
because
sure.
just because you put your meter on the two leads of a safety, like a pressure switch. Pressure switch safety is either normally open, normally closed. So it's either going to be a closed contact or an open contact. If you have 24 volts to one side of it, and that is open, when you put your meter lead on the other side, that'll read 24 volts. Now, if you put your meter lead on and you don't read 24 volts to ground on either wire, you don't know whether the switch is open or closed anyway. But it would have to, you would have to have power. So
Yeah, and-
with power to the device, if the switch is open, you will read 24 volts. If the switch is closed, you will not.
Right. Providing you don't have more than one safety open at the same time in the same circuit.
But no, I'm sorry.
Yep.
My example was at one device.
Right.
So
So that's like we talked about. If you start over on the left side, which is typically you can call it plus, it's not,
Gazetta.
it's AC. And your common's over on the other side,
Gazata.
and you just start working your way in across devices. When you go to the other side of the device that's open, you're not gonna have any voltage anymore.
Yeah.
So, just kinda divide and conquer.
And guys, it's one thing to look at a wiring diagram and you find your start point and you start going through. I did it. I told you last time I used the frigging pencil, and follow the wiring diagrams. And I know looking at the diagram is one thing, but you got to physically put your fingers sometimes on the wire and follow that wire, and follow it to the safety devices. I mean, if you got a furnace, you got a rollout switch. You got a rollout switch. It goes up to the high limit. It goes up to the combustion limit. You sometimes just gotta
It's gotta follow them
follow
through.
the wire.
You can have a wire broken, and if you turn around and don't follow it out, you're
Yeah.
not gonna know it's there. So I mean, that's about as easy as it gets, following the wires out.
Got to do it.
Yep.
All right, how do I test my board to know it's grounded properly?
It's kind of an open-ended question. If you have a board and it has a ground terminal, you're going to want to connect that ground terminal to either the chassis ground or preferably to the same lug that the ground from the power source is coming in from. So,
For the manufacturers also, if they want the board grounded, there's usually one screw
Mhm.
instead of the plastic standoffs, which you'll still have plastic standoff, but there'd be one screw
Right.
that actually goes in. If you look at that, the foot on that is usually made of brass.
Yeah, but like on the Corel EXV drivers, they've got an actual stake on
Yes.
that they want that grounded. So the point being is that if the manufacturer has got something that they want grounded, whether it's with the little spark igniters where one of the corners
Yep.
has got a metal tab that grounds it, or if they've got a ground point on the board, grounds and bonds are very, very important.
Yep.
So
True dat.
Makes sense. All right, let's do another one. What is the difference between series and
You want that one, or can I have it?
Mikey, I will let you.
Okay.
I love your explanation on series and parallel circuits, so I'm going to let you have it, man.
Okay. With a series circuit,
I'm going
and
in.
let's just take a real simple series circuit. I got 120 volts, I've got a light switch, and I got a light. Well, if I turn that switch on or close the switch to complete the circuit, the light comes on. If the
Yes.
bulb is good and if there is in fact power there. Put the qualifiers in there. Now, if I've got two doors, I could turn around and put two switches in parallel so that either one of the switches can now complete the circuit.
Yeah.
But let's take a furnace circuit where I've got 2 or 3 rollout switches and I've got some high limits and I've got some auxiliary high limits and everything. My end result is to not let the gas valve come on.
Right.
So I'm going to put all of those into series. One other thing to throw out there. When it comes to a load, a contactor, or things like that, you don't put loads in series. Because if you put the loads in series, if you want to do this just for fun, take a 120 volt light bulb and put 120 volts to it. Now take that same 120 volt light bulb and put a second one in series, and now the lights are going to be a lot dimmer.
But the strip heaters.
Mhm.
Strip heaters are not series circuits, they're parallel circuits.
Mhm.
Another way for you guys to look at it.
Wrap up here. So if you have any last questions about electrical troubleshooting, leave them in the chat for them to answer. And we'll do a question here that was sent in. What is an allowable voltage drop on a contactor?
On a contactor. So, thanks. Allowable voltage drop. When you're reading and you guys probably do this on maintenance. I don't know, but I've gotten the question quite a few times. Being one of the guys that answers the phone, and you take your reading per leg. Contactor closes, and if you read from L1 to T1, read voltage L1 to T1. Anything over 1 volt means you have too much voltage loss across that contact. If it's less than a volt, you should be fine. But if you start seeing where it's pitted and dark, chances are charred. Chances are that it's going to be a bad contact, and it can't mate complete, and then that also makes higher temperatures, so you see burnt wires on contactors on the inlet side, the incoming power side, because that is cooking not enough voltage leaving the other side of the.
Especially on a 3-phase motor, you can cause a voltage imbalance and cause internal damage to the motor.
Oh yes.
Yep.
Yes.
All right, since
3-phase is a whole different discussion on how to check and.
But no capacitors.
Well, that's true.
There's a really good question in the chat, the long one. You guys can read it out since my mic isn't working right now.
Thank you for sharing all the knowledge. I got that one. You're very welcome. I've been told that there's no way to measure an amp draw on ECMs.
I would
Is that
disagree with
right?
that.
I would disagree with that.
Yeah.
You can read the amp draw on an ECM motor.
You're gonna measure it on your power legs going to.
Yeah, not the
The motor.
control, not
Not
the
the control.
controls,
Right.
not the 5 wires going into for the controls,
Right.
but you're actually going to read your high voltage wires,
Yep.
and it still has a maximum or full load amp on
Yep.
the motor,
Exactly.
on the nameplate. So,
Yep.
but on that same token, guys, look for the tools to be able to test like the X13s. Man, cheap insurance for you guys to be able to figure out whether it's a board or the motor. Don't forget our next Buckle Up, April 1st. That'll be fun. Just kidding. Come and try and stump us on that one. It's gonna be charging and tuning, same bat time, same bat channel. 4 p.m. April 1st Pacific time, right here in Studio Studio B. Mikey, can you tell the guys about what is happening with our forum? Oh,
We are getting ready to release the forum. I'm excited about this because I've tried to get on chat rooms and there are people that just bogart them and don't want to help. The Blue On forum is going to be about helping each other, and it's going to be positive. I've done too much teaching and training over my years, and I found it that the really, really knowledgeable guys would be the first ones to leave because the other guys didn't want to ask their questions. We don't want it to be that. Everybody's question is valid, and we want them to be able to speak those questions, and we want people to turn around and respond to them in a way that's helpful and constructive.
yep.
So
Absolutely.
I'm really, really excited about that because, you know, guys, we're losing too many of the old timers in the trade, and we've got a lot of youngsters coming up. And if we don't help these guys, you know, I don't know who is. I mean, they were talking about doing boot camps for 3 to 6 months of training.
Right.
So you got a guy with 3 to 6 months coming in, and a guy just leaves that takes 50 years of experience with him.
Yep.
You know, so we got to try to help each other.
It's getting tough.
Yep.
And I know you guys like watching us. We like doing this stuff. Update our app. Our app we're constantly rolling out new stuff, more equipment, more information. The app has a new search function for equipment. Look at that. Also, if you're calling in on our tech support line, we have now 3 options. I'm going to talk about the 3 options, not. You can talk about your smart ass 4th option. When you call into tech support now, if you can't find a manual or you can't find a wiring diagram, that is an option. That's option number 1. If you're working on if you're working under 20 ton, that's option number 2. If you're working on over 20 ton, that's option number 3. And Mikey said, just for shits and giggles, that he put in an option 4. If you just want to sit on hold for a couple hours, push option 4. Doesn't go anywhere, so.
Why'd you try it?
Nope.
But no, guys, we're doing this because we want to get you the help you are looking for when you call into tech support. So we're trying to keep the more experienced techs that we have available for the harder questions, and our younger techs are doing the manuals and the smaller equipment. That way you get, you know, we can keep up with the 2 minutes per call. And
Well, we're
yeah.
trying. And we want to get to everybody, and we want to get to everybody as efficiently as possible. So if we've got a great research team that, the app with all the growing information that we're putting in there, our research team can get you a manual or a wiring diagram. But if you call and you're working on a 25-ton carrier and you just click on manuals, that's going to delay you getting your help, because the person that answers the manual line may not be a tech. It may be somebody that's just really good at looking up manuals and doing research. So please that's why we made the options for you, is to make it better and easier. It's all about you guys. So I think I'm done. I think I said what I needed to on that.
Again,
And I just,
April 1st, 4 p.m. for charging and tuning.
yep, April 1st.
We'll prank Mike and Brian, who knows. Stay tuned.
And I hope you all had a good and safe St. Patty's Day yesterday. I know I did. Whoop, whoop. I'm still here. It's all good.
All right, cool. Thanks, guys.
Have a good one.
Peace, guys.